Alright, welcome back everybody. In this video we're going to look at the first couple of examples from the problem solving with vectors lesson. So let's get right down to it. Example 1, an airplane flying in the direction 20 degrees east of north at 475 miles per hour in still air encounters a 50 mile an hour wind blowing from the east. The airplane maintains its airspeed and compass heading, but because of the wind, acquires a new ground speed and direction. What are they? So let's look at what's going on here. We've got an airplane that's flying in the direction 20 degrees east of north at 475 miles per hour. That makes this angle here 70 degrees. And then it encounters a wind blowing from the east. The wind is blowing from the east, so it's heading this way at 50 miles per hour. And so what we have here is we have two vectors. We have the airplane's vector, which is 475 cosine of 70 degrees. 475 sine of 70 degrees. And we have the wind's vector, which is negative 50, since it's going 50 in that direction, and 0. And in order to find the new ground speed and direction, what we're going to do is we're going to add these two vectors together. Alright, so we'll add these two vectors together. We've got 475 cosine of 70 degrees minus 50, and 475 sine of 70 degrees. And this vector will represent the plane with the wind impacting it. Alright, am I in degree mode? Yes. Alright. So I've got 475 cosine of 70 minus 50 gives us 112.460. And 475 sine of 70, 446.354. 446.354. And this gives me the new vector that represents the motion of the airplane. I'm still not done though with this problem because I want to know the new ground speed and direction. The ground speed is going to be the magnitude of this vector. So to find the ground speed, I'm going to find the magnitude of this vector. So I've got square root of 112.460 squared plus 446.354 squared. And the magnitude of this vector is 460.303 miles per hour. So there's my ground speed. The direction, since we talk about the direction in terms of degrees, east of north, etc., etc., the direction of the sum of these two vectors is going to be the arctangent of the angle represented by the two vectors. So the direction is going to be determined by the arctangent of these two vectors. So the these two components of this vector, the arctangent of the y component over the x component. And so I'm going to take arctangent of 446.354 divided by 112.460. and that tells us that the angle is 75.859 degrees, which is 14.141 degrees east of north. Now suppose I wanted to represent the direction instead as a unit vector. I could do that. I would just take the vector that represents the plane's motion and divide it by the ground speed vector, and that would give me the vector form of the direction of motion. So if I wanted to do that, I could take 112.460 divided by 460.303. I missed the division sign apparently. And 446.354 over 460.303. And so the unit vector that represents the direction would be 0.244, 0.970. But like I said, I think in the context we're better off with this angle representing the direction. Alright, on to example 2. Find an equation for the tangent to the curve at the point corresponding to the given value of t. Alright, shouldn't be much of a problem for us here. We find dx dt is equal to negative 2 over t to the third, and dy dt is equal to 3 over t squared. So dy dx is 3 over t squared divided by negative 2 over t to the third. It's going to be negative 3/2 t. And so the slope of the tangent line to the curve is going to be this value evaluated at t equals 2. So my slope of my curve is negative 3. Now in order to write the equation for the tangent line, I still need the y-coordinate and the x-coordinate of the point. The x-coordinate is going to be 1 plus 1 over 2 squared, which is 5/4. The y-coordinate is going to be 1 minus 3 over 2, or negative 1/2. And so the equation for the tangent line is going to be y plus 1/2 equals negative 3 times the quantity x minus 5/4. Alright, that's where we're going to stop for this video. We'll come back in the next video and look at examples 3 and 4 from this lesson. See you then. Have a great rest of your day.